Hi, welcome back. Today we're going to take a look at something called interval and radius of convergence. And this is a really big topic on the AP. So I'm going to work some questions from the homework on page 654 of the Larson 10th edition. This is question number 5, and for question number 5 we had to find the radius of convergence. We talked about this in a previous video, that in order to find the radius of convergence, we're going to use the ratio test. And the ratio test says the limit as n goes to infinity of our next term over a previous term is less than 1. If that is less than 1, then we can guarantee that the series here will converge. So all we have to do is find the nth plus 1 term. Now, another thing that's really nice about the ratio test is these absolute values, because those are telling us that we really don't have to worry about the alternating part, because if we put the alternating part inside the absolute value, it's just going to be positive anyways. So we only have to worry about the part that's not alternating. So let's go ahead and take a moment and find the next term. So the next term, again, without the alternating part, is just going to be x to the n plus 1 over n plus 1. Because remember, we're just replacing the n's with n plus 1 plus 1. And that becomes x to the n plus 1 over n plus 2. So when we write out our ratio test, the limit as n goes to infinity, we're going to take our next term and we're going to divide it by the previous term, or the original term. The next term we just said was this x to the n plus 1 over n plus 2. We're going to divide that by the original, which is, but we're going to flip it, so this becomes n plus 1 over x to the n. And we want to make sure that that is less than 1 right there. So you make sure you have that less than 1, because that less than 1 is telling us we know that this will converge. We want this to converge. We're going to do a little bit of algebra. We're going to simplify this. So we take the limit as n goes to infinity. We have the x to the n plus 1 over this x to the n. Well, to simplify it, we are saying that we have, this is x to the n plus 1 on top, and we have x to the n on bottom. We have one more x on top. That's that plus 1. So when we simplify it, we're going to get an x to the first on top. Now, unfortunately, we can't simplify the n plus 1 and the n plus 2, so we're just going to leave those. N plus 1 over n plus 2. And that, again, has to be less than 1. When we look at the question, notice we are looking at the limit as n goes to infinity. So I'm not really worried about that x, because the x is not an n. So I'm going to factor out the x. And when we factor out that x, it's still going to stay absolute value of x times the limit as n goes to infinity of n plus 1 over n plus 2, and that has to be less than 1. Now, looking back at our old limits from earlier this year, we know that as n goes to infinity, n plus 1 over n plus 2 just becomes 1. So this whole term right here just becomes 1. And I can write that. So this is just going to become the absolute value of x is less than 1. So, well, what does this mean for us? Well, we have a center. The center comes from our Taylor polynomial. That's right up in here at the very top, at the very beginning, is x minus c to the n. So we know our center is equal to 0. Sorry, I should say c is equal to 0. Is equal to 0. Now we have to find the radius. Well, to get the radius, we look at our absolute value. Absolute value says if I'm starting at the center, which is 0, the absolute value says the distance from that center has to be less than 1. So I can go out 1 to the right, and I can go out 1 to the left. And that's going to put me at negative 1 and 1. And what this is telling us that anything in between converges for this. So, so what's so important about the 1? Well, I am going 1 unit to the right and 1 unit to the left. So that 1 is what we call our radius. So this 1 is our radius. So if you need an equation for the radius, after you solve it, if you get something like x minus c is less than r, where r is that radius. So we can go back over here and say that the radius is 1. And there's our answer for question number 5. All right, so let's go to a slightly more challenging one here. Now we want to find, not for question 17, it was saying find the interval of convergence. Now to get the interval of convergence, we are going to have to find the radius. So we're going to go ahead and write over here some things that we need. We need the center. We need the radius. And we're going to need the interval. Now again, the center comes from the center here. That's just x minus c to the n. And there's no minusing or adding here. So our center again is just going to be 0. To find the radius, we're going to use our ratio test again. And again, so this is be careful. Oh no, let's go ahead and take a minute to get our next term here. To get the next term, it's going to be 2 times n plus 1 factorial times x over 3 to the n plus 1. And that's going to become 2n plus 2 factorial times x over 3 to the n plus 1. So let's go ahead and write this out. Remember, it's going to be our next term. So that's going to be this 2n plus 2 factorial times x over 3 to the n plus 1. And I'm going to divide that by the original. 2n factorial times x over 3 to the n. And again, that has to be less than 1. This looks pretty darn ugly, but let's clean up nicely. If we look over here at the 2n plus 2, I can't expand this. This can become 2n plus 2, 2n plus 1. Now, a lot of you guys missed that on the quiz, so be careful. We get 2n factorial, and those actually cancel out. And looking at the x over 3's, we have x over 3 to the n plus 1 on top and to the n on bottom. Remember, the top has 1 more than the bottom, so I can reduce that pretty easily. And so we're going to get, for our new ratio, after we reduce it, we get on top this 2n plus 2 times this 2n plus 1, and we're going to get an x minus 3 on the top, nothing on the bottom, so you can put a 1 on the bottom. And again, just like before, we're going to factor out anything that does not have an n, and that's at absolute value, that's at x over 3. I can reduce it, I can factor it out, because it does not have an n to it. So that's going to give me the absolute value of x. And remember, we're taking it out. We're still under absolute value because we don't know what x is going to be. It could be positive or negative. We don't know. So that's because the absolute value is right there. So the absolute value of x still has to be there. But I can take the 3 outside the absolute value because I know that's going to be positive. And this becomes times the limit as n goes to infinity, 2n plus 2, 2n plus 1, see if that's less than 1. And now it's really kind of cool. If we let n go to infinity, this entire left side becomes infinity. That just is infinity right there. So I have x times infinity, which is just infinity, and that is not less than 1. So we talked about this in our notes and in a previous video. If this is a false statement, which it is, this is saying that there are no values for which this will converge, except 1. And we're going to talk about that, okay? So give me 1. So to find this is saying that if we want to think of our radius, remember, we're looking for our radius. Well, this is saying that nothing will work. So if I start at my center, which is 0, how far out can I go to make it converge? And the answer is 0. I can't go anywhere. If I go to the left, I really can't go anywhere either. So that is telling us that our radius is 0. Now, so when will it converge? Well, this will converge only at 0. And because if we put 0 into our series, look up top here, if we put 0 into our x here, this is just going to be the following series. It's just going to be n equals 0 to infinity of 0. And that's just 0 plus 0 plus 0 all the way over. That's just going to equal 0 if we go forever, not fact. So that's going to converge. So a really quick thing to remember is that all series converge at the center. This one will only converge at the center. So the interval is only going to be x equals 0. The center will always converge at the center. All right, come back to my next video and we'll take a look at another example. I'll see you then.